Welcome back to Path Through Networks. Today we're troubleshooting ticket 11. Users at branch site 1 report intermittent access to internal applications and slow internet connectivity. According to the ticket, a new switch was recently connected as part of the second floor expansion project. Let's verify the issue and see what changed. So we'll go to Felix Anderson's PC and see what we can find out. So let's start off with IP config. Okay, so the network settings looks correct. IP address looks good. Default gateway. So let's see if we could ping out to the internet. Okay, that looks good. And let's see if DNS is working as well. So we'll ping the Google, excuse me, we'll ping google.com to make sure we can get out and DNS is working as well. Since this issue started after a recent network change, let's begin working our way to the switch infrastructure. So what we'll do now is take a look at branch switch 2 and see what we can find out. Okay, so we're in branch switch 2. So let's take a look in there and see what we got. So we'll do a show VLAN brief. Okay, everything looks good there. We'll do a show interface trunk. It's looking good, looking good. Native VLAN is 10. All right. So far, everything appears to be normal. The ticket mentions a new switch was recently connected. Whenever a network issue starts immediately after a change, that's usually where I want to focus the investigation. So what we'll do now, let's look at switch 1 and see what we can find there. So we'll look at switch 1. So we'll do a show interface trunk. Okay. Everything is looking good. So let's do a show spanning tree. See what we find out. So we'll do a show spanning tree VLAN 10. Okay. So the spanning tree. So we're looking at, so we have the root ID, priority 10, and this is the MAC address. The cost is 4, and the port is 23. That's interesting. Okay, so the root ID is on port gig 1/0/23. So let's see which switch is that. So we'll do a show CDP neighbors, and that's switch 3 on gig 1/0/23. Switch 3 is the newly installed access switch. So normally switch 1 should be the root bridge for VLAN 10. Actually, all the VLANs. So let's go over to switch 3 and let's take a look at the config there. Okay, so we're in switch 3. So what we want to do now, let's do a show spanning tree, VLAN 10. And as we can see, switch 3 is the root bridge. We'll see this right here. This is the root bridge for VLAN 10. Switch 3 being the root bridge is a no-no. Because when spanning tree elects an unexpected root bridge, the traffic may flow a path that wasn't intended by the network design. So currently in this topology in branch 1, the traffic is flowing to switch 3 and then up to branch 1. We don't want that. We want the root bridge to be on switch 1. So all traffic flows northbound up to the route. So we're going to go ahead to switch 1 and we'll fix that. What we'll do is a config T. Matter of fact, let's do something else. Let's do a show run section spanning tree. Okay. So the priority was set on switch 1. So let's go back to switch 3 and see what configuration was on switch 3. So we do a show run pipe section spanning tree. And there we have it right there. This is why switch 3 became the root bridge. And that is a no-go. So that contractor that installed the switch probably left that configuration on there. So what we'll do now is remove this command from switch 3. So it'll never become the root again. All right. And let's confirm. So we'll do a show run pipe section spanning tree, and the command is gone. So we'll save the config here. So now let's go over to switch one. All right. So on switch one now, what we'll do is take the spanning tree VLAN for the VLANs, this configuration priority, copy that, and we'll make the priority 0 now. So no other switch will become the root, no matter what their priority score is. Switch one will stay root. And there we go. Let's confirm the config. Voila, we're good. And we'll save this. Boom. So now we'll run a show spanning tree VLAN 10 to check the root bridge status now. And that's it. So now we see switch one is the root bridge for VLAN 10. And if we do show spanning tree, switch one should be the root bridge for all the VLANs. Even VLAN 1, this is the root bridge. This bridge is the root. This bridge is the root, and so on and so forth. And we are good to go. So now we'll head back over to Felix's computer and just run a ping and see if there's been some changes. So we'll ping the gateway 10.30.10.1. Okay. And let's go ahead and ping google.com. Okay, much better. So as we can see, the ping results before, when switch 3 was the root bridge, we see some latency there when we ping Google, right? Then once we were able to identify that switch 3 was the root, we were able to change and make switch 1 the original root bridge again, and the ping times have reduced to the gateway and to Google as well. So in this ticket, users reported network performance issues after a new switch was connected during an expansion project. During the troubleshooting, we discovered the newly installed switch had become the STP root bridge for VLAN 10. After restoring the intended root bridge back to switch 1, network operation returned to normal. Thanks for watching Pathview Networks. My name is Darryl Foy, and I'll see you on the next ticket.